I would like to present our work on effective scenario definition for diverse applications of simulation. Effective scenario definition is important since it allows to exchange traffic spaces and scenarios between different simulation tools. Both traffic spaces and scenarios are based on the Pegasus, the well-known Pegasus 6-layer model. We're using the OpenDrive standard to describe the traffic space maps, and we're using the Open Scenario standard for describing the logical scenarios. Both scenarios and traffic spaces are publicly available and extendable. They can be used by third parties for testing, demonstrating, and comparing simulation tools. Here we see two exemplary traffic spaces and scenarios. This is a simple intersection with a right turn of the ego vehicle, and down below we see the left turn with oncoming traffic on a complex intersection. On the website we see also the recording videos to these two scenarios. Here the public GitLab space, or the link to the public GitLab space, is shown where you can download the scenarios and the traffic spaces. We also have a broad documentation of all scenarios also available at the GitLab space. On the right-hand side, we see a road generation tool developed at the Technical University of Aachen. The OpenDrive standard only allows to describe concrete scenarios. But with this road generation tool, it's also possible to have a logical description of road networks. So this means you can systematically and automatically vary the road maps. So for instance, intersection angles, curvatures can be automated systematically during the course of the simulation. So this allows a more logical description of the road network than actually only by OpenDrive. Finally, also the logical description of scenarios was improved during the course of the project. While at the beginning we had to use non-standardized Python expressions, the ASAM Open Scenario standard was developed further during the course of the project, that in the end we could use OSC 1.1 standard for the description of logical scenarios. So to sum it up, we found that the scenario definition directly affects the testing efficiency through its performance. Also, the set-level scenario definition helped to refine the ASAM standards, OpenDrive and OpenScenario, for example. And existing standards for scenario definition still have room for improvement. So, for instance, material properties could be described more in detail to be used in simulation. And finally, the non-native use of standards within tools can lead to problems when exchanging maps between different simulation tools.